Okay, date is November 16th, 2018. I'm recording. This is ITSC 2309 at Collin College, Frisco, Texas. And let's see, this is the regularly scheduled 10 o'clock Friday meeting of the class. So today, let me look at what we're doing. We have two more class meetings after today, and we have, let me go back here, modules. I have decided that I'm going to get a little bit out of order in the modules. I don't think we're going to get a test 2 in, just 2 days. We're short a week this semester due to Thanksgiving. We do not meet next week. Then we meet on the 30th and on December 7th, I believe it is. Yes, we meet on the 30th and on December 7th, and then that December 7th is the last day of class. So we just did module 11, and I believe I have made that assignment. Yes, it's due today. Okay. When you do module 11, be sure that you run your Create AP SQL. That's found in module 2, page 5. If you don't have it on your disk, you probably have it on your I told you to put it on your flash drive or whatever you're using. What that will do when you run it, it will reset all of your tables in the AP database, and it will bring all of the dates to a current state. So if you just ran it once back in September, all of your dates, there are no invoices that are due in the next 30 days. So when it asks you to find those, you won't find any. Everything's in the past tense. So time marches on.
That's not going to change what the correct query that we see.
The query is correct independently of the data. Right. The query does not matter what data it runs on. If it's correct, it's correct. So I would have the same data copy that you do. But even if I don't, that doesn't change anything. Okay, I'm gonna jump a little bit ahead now. I'm gonna jump over one module. Database design, we are definitely coming back to module 12. That'll probably be at the last day kind of a thing. Today, I'm going to go ahead to 13, and I'm going to go creating and maintaining indexes. Okay. Let's see, there was something, well, we'll have time for a review towards the end of this class. I want to look back at where we've been. So this will be kind of our last, well, no, it won't be our last SQL topic. Database object is a something that you create. So create a table is what we know how to do. So far, that's about the only thing we have created. But the database object is a database table is an object. The other objects are, believe it or not, the primary key is an object. Right? When you create a constraint that is a primary key, it has to be unique in the database. Not the name of the field, the name of the constraint that creates your primary key. That's why I always use the table name _PK. That way I'm guaranteed that it will be unique. If I try to name another primary key and we're going to see why that is today. Okay. When you create an object, excuse me, they should be bracketed by a go. Now there's nothing special about this thing go. Go is just a name. It's just a command to the SMS that says, okay, send all that stuff to the server, start a new batch. By the way, over in your tools, you can change go to be something else. If you want it to be teetotally humswoggled instead of go, you can change it. I recommend you don't. because Go has gotten pretty standard. But Go is not in the SQL language. It's just a directive to the SMS that says, okay, make everything above that happen. Start a new one. Oracle is a little bit different. Oracle executes it each time, but basically when you see Go, that is unique to SQL Server. Okay. Sequences. Okay. Let's talk about let me
excuse me, I wonder if you can help me. I'm having some trouble finding a book. Yes, they all seem to be mixed up. Mixed up? Look all right to me.
I'm going to pause the recording for this. I paused the recording for the YouTube. If you want to watch the YouTube, let me get this. Here is the YouTube URL. I can put that in the notes. Okay, that goes with our discussion today. Excuse me. And make sure I'm recording. Okay. Testing. Okay. Indexing. Now, what that was, believe it or not, was a discussion of the indexing. They had poor indexes on that library. How are libraries laid out? Actually, yes, they are laid out there. They are indexed alphabetically by title, but how are the books stored on the shelves? Well, based on the call letter, they are categorized by subject, but they're given a call. Each book has a unique call number, and it's got both letters and digits in it, and that is a primary key. So if you know that, you can go directly to the book that you want right on the shelf, because they're sorted by that. Now, it doesn't matter whether they're within that they're sorted by title. I mean, that the Dewey Decimal Number 5,000,003 is right next to the 5,000,004 doesn't necessarily mean much to me finding it. If I have that, I go straight to the book I want. I go straight to the shelf, find the book in there, and it doesn't take me very long to find it. If I don't know that, and I most of the time don't, I have 3 other indexes. Now, I don't know whether all of you are old enough to remember when we had physical card indexes in a library. Do you guys remember that? See them in movies. There'll be drawers, you pull them out. Don't pull it out all the way and dump all the cards on the floor. The librarian will not be happy. Although most of them won't come out unless you have a key. And they take up a pretty big chunk of real estate in the library's lobby. Now they're all electronic, of course, but they still take up a big chunk of real estate on the library's computer server. So just because they're not physically there doesn't mean that they're not there. They're there, and they're still taking up space. We're going to talk about how much space a library takes up, an index takes up. There are 3 main indexes in a library. Does anybody know what they are? What would you index?
Primary.
Well, there's only one primary key. The primary key is the call number, Dewey Decimal System call number. Author. They're indexed by author, indexed by title, and one more. You could index it. Do people really search by books on publishing date? Okay. What else would they search on? Author, title, and genre, subject. Subject matter in one or two words. So that's usually a compound one. So if I want to search on something, I could, if I wanted to search for books on whales, I could search whales or cetology. That's the study of whales. Great big fish. Well, it's not a fish, but whatever. Aquatic mammals, right? If I wanted to find a specific book, I could search for the title Moby Dick. And if I wanted to find the books by Herman Melville, I could search on Herman Melville. There I'd find Moby Dick, I'd find 2 Years Before the Mast, I'd find Billy Budd stories, lots of other stuff that he's written. Now, in that skit that we just watched, they had indexes on what? The color of the book, size of the book, whether it's thick or thin. What's wrong with that? Well, obviously, it was a comedy. That's not what people look for. Nobody goes in and looks for a book that's red. Nobody goes in and looks for a book that has 326 pages. Now, I'll bet the number of pages in the book is in the database somewhere. I'll bet somewhere on that index card, if you're talking a physical index card, which is a database, by the way, that physical index card has the number of pages typed on it somewhere, but they're not sorted by the number of pages. I'm sure it has all that stuff. I'm sure it has lots of information there about that book. The color, the size, the oversized, the size would make a difference. But I'm not going to be searching. I want to read an oversized book today. So I'm not going to go to the index trying to find one. I'm going to find the book I want by author, by title, or by subject. That's going to give me the position on the shelf. Okay. Position on the shelf is called a clustered index. That means that the books are actually stored by that value. That is the primary key. Every book has to have one. Every book has to, it has to be unique. Okay, so primary key. Very important little deal there. The others, do books have to have a unique title? No. I can have duplicate titles. Does the author's name have to be unique? No. Subject probably won't be unique. I'll bet you it isn't. Let's see. If I wanted to categorize a database on Frisco, Texas, for example, well, I don't know how many people live in Frisco. How many do you think? Oh, I'll bet it's probably closer to 300,000. Yeah, 250 to 300K. What would we, if we were storing everybody, keeping track of people who were, I don't know, who lived here as a tax roll or something like that, what would I use? What would I index? Well, clearly their street address would make a good index. That's probably as good as I'm going to get. Phone number would make a pretty good index. I'm not guaranteed it's unique, but an index, just to have an index, doesn't have to be unique. It just has to be almost unique. What about zip code? Would I index zip code? Why not? Oh, okay. There's only, I'm going to guess 15 or 20 in plain. I'm just guessing. I agree with you. Okay. I agree with you. It would narrow down my search, but think about it. When I search an index, there is a cost to going to that catalog finding the card I need. So that's one access to something. I had to look it up there. Then I have to go look it up on the shelf. Now, in a database index, it's really not just one card catalog. It's really cascading card catalogs. So I might have 3 layers of card catalogs. I go to the first one. That tells me which subcatalog to go to. And then there might be one more below that. So I've gone down through 3 lookups, and then I go straight to the shelves. In a computer, that's the way it works. Telling you how an index works, if you ever get to a advanced graduate level programming class, you might get to write an index. It is a monster. Okay. It's a monster of a lecture just to try to explain how they work. But basically, think about it as I have a master index at the top level. Under these, I have another row of sub-indexes. Under all of those, I have another big row. So I have to go through 3 index boxes. Then I finally get sent out to the shelves. If I index on something where I have many, many values that are duplicates, and that is called, it has a high cardinality, the count. It has a big count. How many people will live in a certain zip code? 20 or 30,000, I guess. Could. Of those 30,000 people, I'm probably going to have 1 on every disk page. Even though an index in theory makes it faster, it would be a lot easier for me just to start at the beginning and go across if I wanted everybody from a particular zip code. Now, I'm probably going to have to access every shelf in the library to find all of the books with red covers, probably 1 on every shelf. So I would do better to take my cart and just start going through the books. Okay. Remember, I can search at about several million books a second. So, you know, it won't take me too long. I mean, a 10-second search is considered a long time in database world. Whereas if I went through an index, it would actually slow my search down. So by choosing a poor index, I can jerk my database around. Okay, some rules on indexing. A primary key constraint is an index. An index exists outside of the database table. It's an object in the database. So in the AP_DB database, we can only have 1 index named invoices_PK. That's an index. Now, it's the name of a constraint, and when it's a primary key, it also creates an index by that name. Okay. Okay, and it is the index by which everything is going to be stored in the database. So when you say it's a primary key, not only are you saying that it is unique and it is required, you're saying that all of the records on the disk will be sorted by that, generally. I have a way to say do it some other way, but I'm not concerned about that right now. For right now, the primary key is what we call a clustered index. A clustered index is the one of them. There can only be 1, and the data are stored by that. Can you have something besides the primary key? Yes, you can, but the primary key, then you have to do what we call uncluster the primary key. They have to be sorted some way. So it is very, very bad to have a database with no clustered index. That's why we require you have to have a primary key. Otherwise, it's just a big glop. It's not sorted any particular way. Everything that uses it just has to go in there and search through the whole thing. A unique file, field name, a unique constraint is also an index. Okay. Constraint, T-name unique, is the same thing as creating a unique index. Oops, I forgot to give this its name. There. That wouldn't have gone very far. I have to give the index a name. So you can't do both of these. You can only do one of them. There's no reason to do both of them. There is no reason to create an index on a primary key. There is no reason to create two unique indexes, a unique constraint and a unique index. You're redundant, redundantly redundant. And besides that, you're saying the same thing twice. I don't really want to go into that right now. You can. I have never written a table where I wanted something other than the primary key to be the clustered index. If I had a clustered index that was unique and required, that's the primary key. Duh. I don't need another one. If it's set up with something like a sequence, an identity, I'm just giving them numbers 1, 2, 3, 4, 5, so I can tell them apart, and that was the primary key. But maybe I want the index. Maybe I want it to be clustered by something else. Then I can still leave that 1, 2, 3, 4, 5 as the primary key, and I can say uncluster that and cluster it according to telephone number. I'd be trying to get away from that. A lot of things I try to do. Life is always a trade-off. And lots of times you're stuck with things that other people do. And I'm stuck with some stuff in the AP database, by the way, that I'm going, what moron wrote this code? Now, the person who wrote that code, I'm quite sure knew what he was doing with respect to the SQL Server. And he did that just so I could sit here and say, this moron doesn't know how to write code, And so he's got to give me something to gripe about. We'll go in and look at some stuff that he did with the primary keys. That's just wrong. Okay. So create an index. Now, creating an index is easy. Create an index, all I have to do is say, creating an index is easy. Creating an index is simple, but what it's doing is not simple. It's just simply this. Create index. Make a note of that index name. Bingo, done. Nothing to it. The decision to create that index is something that you need to put some time and effort into looking at carefully, because it has a big cost. Think about what the cost of an index is. Let's go back to the library and let's go back to those big index cards. That's what they are. And what has to happen when a new book comes into the library? Assume we have 3 indexes created. So the indexes are author and title and subject. The librarian has to sit down, make out a new card, make out 3 new cards, decide where it goes on the shelves. So give it its Dewey Decimal number. It seems like I was hearing that they have changed that name of that. It's no longer Dewey Decimal System. Is that? I need to Google that and find out, make sure I'm saying that right. Library science is not my field. anyway, so he or she has to put the card in the author's index in the right place, has to put the card in the title index and in the subject index, alphabetically, all of that. Then the book can go to the shelf. If a book leaves the library, you have to keep the indexes update. If I don't ever want my books to change title, I do not like it when something in that index changes. That's another thing about an index. I don't want that indexed key to change real often. What would be an example? Indexing, your age. First place, I'm not even going to store your age in the database. I'm just going to calculate it from your date of birth. Your date of birth doesn't change, but your age can. Okay. I was reading an article about a guy in, what was it, the Netherlands? Anybody else see that article? He's 65 and he's petitioning the government to be 45. You see that? I identify as a 45-year-old person. Now, so what? He wants his birth date changed. You can be 45 if you want to. I mean, hey, I don't have a problem with it. But your birth date isn't going to change. That's on your birth certificate. That's kind of locked in. I want an index. I can index your birth date. Okay. It wouldn't make a terrible index. Many times it's your birth date and last name. That narrows it down a little bit. So I can build an index on more than one field. I don't like that real well. I want to think, how can I get around that? Okay. Is there something I can do that would let me not have what they call a composite index on more than one field? Because unfortunately, yes, you can. I'm going to show you an example in our database. There's an example in the AP database of a primary key that is two fields.
And they're not both unique, right? Just
together, they are unique, and neither can be null. Yeah, both are required. They are unique together. I do not have an end. I'm going to talk about that when I get there. What time is it? Halfway to 11 o'clock. Okay. When do you not create an index? Okay. Small tables that I expect to be tiny. In the advanced class, we're creating a table, and we never expect that table to have more than 8 or 10 or maybe 15 rows maximum. So it's some statistics. I mean, if it ever gets more than 15 rows, I'm really going to be surprised. I don't need indexes on that table. Now, I created a primary key. There are some reasons I need an index. And as we go into what we use an index for, that goes into the next class. So right now we're just looking at SQL. How do you create an index? Like this. Now the word clustered goes in here. So clustered or non-clustered. Well, you only got one clustered index, primary key. So if I don't say anything there, what do I get? I get a non-clustered index. You don't have to say create non-clustered index, but if you Google index creation, it'll say, create non-clustered index, and then some other stuff. I don't really need, most of that other stuff is taken care of unless I get into really esoteric stuff. So if I'm not changing the primary key from clustering from the primary key, I'm going to try to always leave it that way. Do not index a table that is small. Do not index a table, other than a primary key, do not index a table that is infrequently searched. Your database maintains statistics, and you have a way to see them, and that's, again, in the next class, where I can tell you how often this table gets triggered. Really needs a full class for that, a full 3-hour class for database tuning, but it's probably beyond the scope of the community college. Okay, how often did we search that table? When we searched that table, how did we do it? If we didn't have, you know, they only look at that table once in a blue moon, it is not worth maintaining an index on it. Do not index a primary key, do not index a unique constraint. They already have them. Do not index a field, or you should refrain from indexing a field if you can, that is going to be changing frequently. I don't like indexes that it changes a lot. A primary key almost never changes. Can the primary key change? Yeah, but you're really grinding the gears on your database if you do. Try going down to the Social Security office and telling them you're tired of your Social Security number and you'd like another one, please. Huh? No, you're stuck with it. Okay. Same thing, your driver's license number and all that.
So you said it's not worth indexing a small table.
For the most part, these are guidelines. These are rules of thumb. If it's only got 8 or 10 rows in it, give it a primary key. That'll be an index, and it's not worth putting indexes on other fields. Okay. Putting an index on another field will vastly speed up your time to search that by a factor of 10,000. So if I have to search, I just have to begin at the beginning of the table. And if I don't have an index and I want to find the book name, if I want to find books by Herman Melville, and I don't have an index on the author's name, I have to start at the beginning of the table and just plow through it. Okay. How long will that take? Well, I don't know how many books. A database access is probably a 15 millisecond to the table, just to read the table. It's probably just, well, okay, a database, a disk read today is about 5 milliseconds. Nice fast disk, and databases are on fast disks, so 5 milliseconds is fast. Times how many books are in the library. If I have 1 million books, that's going to be, well, let's see, a millisecond is 1,000th of a second. So that's 1 million milliseconds, or 10 seconds to go through that whole million row table. Okay.
So you do it by index at constant time?
If I do it by index, it's logarithmic time, meaning that I go in, I search the first level. That takes me to the second level. That's another disk read. That's 10 milliseconds. Might go to a third level. If I have 1 million records, that's probably a third row. So 5, 10, 15. Then to the stack, that's a 20 millisecond access versus a 10 seconds table scan. We're going to talk about views. Views are a different topic. Okay. I might introduce views today. Okay. So index is going to speed me up a lot, but there's some things that I don't want about an index. I don't want little tables. I don't want a primary key. I don't want a unique key. I don't want a value in my index that's changing a lot. I want my indexes to be pretty much static. I want my index to have what we call a low cardinality, meaning I don't want it to have a lot of the same values in the index. Okay. So if I specify a phone number, how many people will I get that have that same phone number? Let's say it's in the database. Well, I know I got 1. Could I have 2? Yeah, I might have 2. Husband and wife might have the same phone number. Could I have 3? Yeah, maybe they got a couple of kids. Maybe they got a dog. So I'm going to find, 3, 4, maybe 5, but that's still not very many. If I'm returning about 5 to 10% of the database, it's too big. The cardinality is too high. So I want to get rid of that. So let's see, what else? So almost unique is what I want. Index does not have to be unique, but it has to be relatively unique. And somebody, English major always says, no, 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 you never qualify unique. It's either unique or it isn't. It's not pretty unique, but I'm going to say pretty unique. Well, that's a different story than not changing often. You know, can it ever change? Yes, it can ever change. Does it have to be absolutely unique? No, it doesn't have to be absolutely unique. Other thing I like about a index, I like that value that I'm indexing to be as small as possible. Okay, I don't want to build an index on a varchar 500 field, because that's going to make my index really, really big in terms of storage, because I'm going to have to reproduce that on every index card. Okay. Okay. So there's a few guidelines. I think they're in the module. Clustered index, I don't have to say, okay, the storage cost of an index is about, this is a rule of thumb. Later, as you get into what an index is, you'll calculate it more exactly than this. Take the size of the indexed field. How many bytes is in that field? Well, if it's a varchar 60, there's 60 bytes there. Just allocate the biggest. Times n. N is the number of records. How many records are in that database? And you're looking down the road. So you're saying, well, given how fast my business has grown up until now, what will it probably be in 5 years? I wouldn't look much beyond that, because after you get beyond that, I don't know, but I can probably make a guess as to, given constant rate, given that I keep doing what I'm doing now, what will be my database size in 5 years? How many records? So I take a rule of thumb and then I add a little bit to it. Times log 2 of n. In other words, 2 to what power is n? So like 2 to the 20th power is pretty close to 1,000,000. So log 2 of 1,000,000 would be 20. Log 2 of 1,000, well, 2 to the 10th power is 1,024. So log 2 of 1,000 would be about 10, always rounding up. N is the number of records. So the size of the field times n times log 2 of n. So n log n. Thus, with 1,000,000 records indexing a char 16 field, how big will my index be? Well, it's 16 times 1,000,000 times log 2 of 1,000,000, always rounding up. Log 2 of 1,000,000, if I round up, is 20. Actually, it's 19 point.
Is that the number of layers you have?
No, this is a rule of thumb. The number of layers is a logarithmic, because it's getting, each one is a power. It's not quite this. Log 2, it just gives me an idea. So I'm trying to get a rule of thumb about, and then I'm going to push that number a little bit when I'm figuring my storage space. And you ask what? It is. Yeah, you can use your calculator. Lots of times have you had algebra, college algebra? Okay. Okay. Logs are something that you pretty much are going to have to deal with if you go into computer science. We use log 2. There's another one called the natural log. And most of the time in computer science, you don't have log 2 or log 10. You just have the natural log. And from that, you can convert to any of them. How do you find it? Button on the calculator. Let's see, am I scientific? Let's see. Yeah, let's go 1.
By default, it's phase 2.
No, I think the default is base. No, default is base E, Euler's constant.
Wait, I thought that was natural log.
It is. That's natural log. So with that, if I take a log,
That's base 10.
that gives. Yes, that is base 10. Okay. Well, I'm surprised. Should say ln somewhere on
Yeah,
here.
that's
Well, that's what base E is. I'm sorry, I don't have a base 2 on my calculator, but most calculators have an ln, and I don't want to get bogged down in that. Think of it this way: for every for every period increase from 1,000 to 1,000,000 to 1,000,000,000 to 1,000,000,000,000, the log increases by 10, log 2. So think of roughly 1,000 is log 2 of 1,000 is 10. Log 2 of 1,000,000 is roughly 20. Log 2 of 1,000,000,000 is roughly 30. And then in between, you just kind of interpolate.
like another way to think about it is like for log, think about how long the number is when you write it out. So like log, yeah. So like as it gets the number gets longer, you write it out. That's
Yeah. That takes up. If I teach algebra, I usually spend 3 or 4 days on logs. Okay. Anyway, if log 2 of 1,000,000 is 20, then I have about 320 million bytes, or about 1/3 of a gigabyte of disk space allocated to that index. Today, that's not huge, but think of it, that's every index you have. So the primary key is going to get that 1/3 of a gigabyte. So I can tell you about how big my table would be. You know, my table is just the size of a record times how many records do I have, but I have to figure in these indexes too, primary key and anything else. Okay, let's go back over here. Next. Database indexing. Let me see if this is any good. Okay. I guess I need to update that. Database indexing, and indexing makes the query fast. Let's see. Maybe I'm getting a little too technical here. A picture of a filing cabinet. There's some examples that are like that too, Ronnie's video. I want to find books that contain 376 pages. Nobody ever searches for a book with 376 pages. Don't worry about it. Finding a book by its cover, the color, red. How many red books do I have in the library? That's a terrible index. Sometimes a book comes with abstracts. These are a one-page synopsis of the book. Why would I not index the abstract? It's too big. It's going to cost me too much to index it. Besides, whoever searches on the abstract? Here's one that's going to change frequently. Every time a book gets checked in, checked out, that index would change. For general guidelines, don't index fields that are searched infrequently. Don't index fields that have very few distinct database. We want a am I calling that a low cardinality or whatever it is? It refers to the idea of cardinality. If by specifying one value we return over 5% of the database, that's not a good index. We want the field to be as small as possible, and we prefer to index static data. So 3 and 4 say we do like these, as small as I can get and static, more or less static, changes infrequently. Okay, let me get on through this. Primary key index, okay, here's a unique constraint. So demo PK is an index, and demo unique is also an index. I could not have two indexes named demo index. Right? My indexes have to have unique names in the database. Pretty easy. If I've met my criteria. Next. Okay. I'm not going to go into this B tree a whole lot. We'll get bogged down in here and we'll be here forever. Basically, here is the first layer, the first file cabinet I search. From that, I'm searching for the value 27, let's say. Is it bigger than this, or is it less than or equal to that 19? Well, I want 27. It's bigger. So I follow this arrow to the next disk page. Each one of these is a disk page. So I search this one. Now I can search across here a whole lot faster than I can do a disk access. Disk access, 5 milliseconds. Searching in memory is nothing. Okay. We think in terms of database, we think accessing memory is zero cost compared to accessing the disk. Okay, so let's read this one into memory. There's another 5 millisecond cost right here.
B plus trees are a type of balanced search tree.
I'll let you read that.
So when you're searching, the index is like loaded into memory?
Usually the root of the index is pinned in memory as much as I can do it. I'm going to put those guys in memory because I'm going to be using them a lot. We have an index because we use it a lot. So first time you read it into memory, it's probably going to stay there. So I probably get this one free, then this is 5 milliseconds. Is it greater than 24 or less than or equal to 24? If it's less than or equal to, I follow down here. If it's greater than, I follow this one. So it's greater than 24, less than 30, I follow this guy. And what was I searching for? 27. Aha, there it is in the index. Now I go straight to the tables. So that gives me the disk address of it. So I've had to read or touch 1, 2, 3, 4 disk pages for a total of about 20 milliseconds. And I don't know how big this guy is. So that's the only introduction to the B tree I'm going to do. I'm not going to ask you a question about this level of indexing. You can watch that video. It's a pretty decent video. Lets you know just how complicated these things get. Monstrously complicated data structure. Optimized for searching. Detailed discussion is beyond this scope. Okay, points of the ones that'll be on the final. When do we index a field? Frequently searched. It's important. What fields might be important? Foreign key is a good candidate, unless there's some other reason not to do it. For example, if I were maintaining a database and I have a person and phone numbers out there, I might not index the phone numbers. Yeah, primary key, foreign key that takes me, no, the phone numbers with a foreign key that takes me to the person. So, or departments, that's a good one. So I have maybe 10 departments within a company. I want to make sure that nobody uses a bogus department number over here in this table. So I might set up my departments, you know, R&D, human resources, finance, referencing the table. And now if you want to create a new department, you have to put it in that departments table. It just keeps you from putting in bogus data. I probably wouldn't index that one. We index a field when they're widely dispersed. I say pretty much unique. SSN is good. Address pretty good. Phone number is okay. Zip code stinks usually. There might be other things. Maybe you have maybe you're sorting your stuff by zip code when you print it out to take it. You get a better mailing rate if all your stuff is zip coded and rubber banded by zip code when you take it to the post office. So there might be a reason. We like these things. We like small data fields. We like data that do not change much. Do not index primary key or unique fields. Next. Take a quiz. Okay. It is now 10:55. Are we ready for a break? Everybody says yeah. Okay. I'm going to show you some examples in the our database, the APDB, that are bad that they did. Okay. I'm going to pause the recording. Let me ask, is there anybody out there participating? Anita, Doug, or Mark, you guys have any questions?
This is Doug. Not so far, thank you.
Okay.
Okay, I have a question for the final exam.
Go ahead.
Would you just give the questions like the last time you did, like a small problem, so it's going to be the big whole database? Or
I'm sorry, I don't understand the question.
the last time you the exam you take the midterm, like it's going to be the same as the final? The final is going to be same as the midterm?
Exactly the same. It'll be real close. It will include the material that we have covered since then. So it will include subqueries. So you need to be up to speed on your subqueries. I have time to do a quick review. For an index, go ahead.
So we have 3 more weeks before the final exams?
We have 2 more class meetings after this one.
Okay, so there will be no class on the Thanksgiving break?
There will be no class next Friday. That is correct.
Yeah, okay. So 2 more classes, and then so the module 13 is the last?
Yes, it will be.
Okay, great. So the next 2 classes will be review.
Yeah, we have 2 more modules and 2 more classes.
Okay, great.
Okay. So we will meet on November 30th, and we will meet again on December 7th. Okay. I'm going to pause the recording.
So what you are telling something about the test, the final?
I'm going to talk more about that. I have a practice final that I'm going to put out there for you, and the final will be given in the format that the last one was, where it will be open for a period of time. The last day to turn in assignments that are late will be December 7th, unless the due date falls after December 7th. In that case, it's the due date. I say that because I have to have a way to say, okay, no more module 3s coming in now. So after December 7th. Now, if I give module 13 or something, and the due date on that is after December 7th, that's fine. That's the due date. Okay? Okay, pausing recording. And we are back from our break and resuming the recording now. I guess I better check it and make sure, okay, we're up and going. I'd like to call your attention, please, to the table in our database that is called invoice line items. Okay. And let's drill down into that a little bit, into invoice line items. And let's look at the columns of invoice line items. And what do we notice there? I got 1, 2, 3, 4, 5 fields. And as you're looking at those fields, what do you notice about them? We have one primary key that consists of 2 fields. We can't have 2 primary keys because primary key is clustered, but I have 2 primary keys and 1 foreign key taking me to the account. Okay, so the primary key is built on invoice ID and invoice sequence. Okay? Together they have to be unique, and neither can be null. Let's go over here and let's look at this. I'm going to right click him, the table, and I'm going to say edit top 200 rows because I want to bring it up in a. Now let's take a look at what we have in that table. Here's the invoice ID, and here is the invoice sequence number. Trying to highlight it, it's not highlighting. I ought to be able to highlight a column, but I can't. Okay, the first one, invoice ID. Notice how it's going. It goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12, 12, 12. Together they are unique. It's a two-factor primary key. It is the invoice ID and the invoice sequence number. And in my humble, not so humble opinion, this stinks. Look what's in the invoice sequence. 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, until we get to 12. Then I got 12, 1, 12, 2, 12, 3, 12, 4. 13, 1, 14, 1, 15, 1, and so on until I get down here later. Oh, here it is. 78. I got 78, 1, 78, 2. Then I start with 79. Do I have any more?
How's there null down there?
Well, that's just a record that I haven't put in there yet. That's the next record coming in. Right, yeah, it's just a phantom record that's down there, placeholder. This is terrible. These guys right here. How could I do this better?
Have like a line item ID?
Okay. Well, don't I actually kind of have one? Sort of. If I made a couple of tweaks to it. What is invoice sequence number beside, well, together they're a line item ID. Okay, if I were designing this table, the invoice ID would be a plain old foreign key to the invoices table. It would be there. The invoice sequence number would be the primary key standing alone, and it would start with, I can start with 1 if I want to, or I can mix them up where it doesn't look like it's just numbering it, but I could just number it. I have a way to number it, by the way, where I can say I want to give it an automatic number, but I want to just number it let the system number it. And I don't usually do that. If I'm going to let the system number it, I'll just let the system start with 1 and plow on through it. So you would have the sequence ID would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then when I got to 12, I'd have 12, 12, 12, 13, 12, 14, 12, 15, 13, 16, 17, 18, and I'm just numbering again. Now, what's unique there? The invoice sequence is unique. That's my primary key. Can I tell you all of my records that belong to invoice ID 12? Sure, it's a foreign key. Just simply search on it. I'll probably build an index on that foreign key. A foreign key is probably indexed unless there's something screaming at me that says don't index it. In this case, my invoice ID would certainly be indexed. It's a great index.
So as of right now, this invoice ID has no foreign key relationship.
I don't think it does. Let me look at keys.
Oh, it says that. It says comma FK.
Okay, yeah, it is a foreign key. So the invoice ID, The invoice ID is a foreign key. I can see it right here. I should be able to see it here. Invoice line items is both of them. F key. Yeah, I think this is it right here. Yes, I can see that it is a foreign key. It would not make sense to have it not be a foreign key. I would take it out of the primary key. And then I would renumber I would look at a different schema here. Now, if I have a million rows in here, this is going to get expensive to do. And during the day, I wouldn't do it. But my next downtime, I'm going to go in and I'm going to renumber the invoice sequence as, well, maybe not. I don't know. I got to think about it because doing this is really going to be bad. What am I going to do? I'm going to break all of my code that I have written for this. And in the next class, we're going to write code because SQL itself is pretty simple. We've covered most of SQL. What's SQL? It's tables, table joining, select from where, joining tables, subselects, unions, group by, aggregate functions. Pretty much that's about it. So really, there isn't much more I can do with SQL. I need a language to wrap around it where I'm now having multiple SQL statements all interacting with everybody. Okay. Now these indexes become important. But I'd take that out. There's another problem with this table. Let me...
So before we move on,
Mm-hmm.
is there any advantage, like, to having it the way they have it, or did they just make it that way to?
They just make it that way to make your life miserable. No, I mean, what? Tell me your question again. Is there any advantage to what?
Is there any advantage to having a composite key the way they do?
No, there is no composite key. A key that an index on more than one field is typically undesirable. Now, there may come a time, for example, we're writing code in the advanced class that I have two fields. I have two, we're writing a game, and I have two players, and I want those two players to be unique. In that case, I would create a unique index on player 1, comma, player 2. So sometimes there is, but I almost never want a primary key. If there's any way around it, I don't want a primary key that is on two fields. Sometimes I'm stuck. I'd rather not. So normally what I would prefer to do is give them a unique number. In this case, I would definitely give, let me get back to my, I would definitely make invoice sequence number be a unique, just a counter. Or I can give them something else. If I don't like that, I can give them random numbers that look random that have no duplicates. And I have a way to do that. Okay. Let's look at something else that's real bad about this table. Notice the 1, 2, 3. Notice the fourth column over. I'm going to just, I can't highlight down a column, so I'm just going to highlight that one right there. Notice that column. What is that column? Invoice line item amount. Okay. Now, while I'm here, I'm going to go look at invoices. And I'm going to say, I want to see the top 200 rows of invoices. Notice the column here that's called invoice total. Let's see, 12. That's a currency field. And so the invoice total is $662. And if we go back here and look at this one, if I added up all of these guys,
That's about right.
61. No, it doesn't look right.
Oh, no, I was very roughly estimating.
Okay.
Actually,
Well, this one I've got, let's see, 61 cents. So there's $1. So 50 plus 75 is 125. Looks like I'm off by a penny. And I think that is, let me go over here. Let's check it. Select sum. Let's see. I guess first I better get my U's. Invoice line item amount, I believe that's what it was, wasn't it? Invoice line item amount. Where the invoice ID is 12. So I'm interested in that one, and I believe that's the one that does not jive. Execute. Yeah, $662.01. But let's go back and look at the invoices. The invoices, it says $662. We're off by a penny. And you say, oh, that's not a big deal. That's a big deal. Okay, I made it be that. I put it in there. Now, what's wrong with this? Why are we here? We have something, we're storing something in our database that I can calculate from existing data. As a rule of thumb, this is bad kimchi. I never want to have I never want a value in the database. So this is like I store your age in the database. So I have your birth date, right? And in a field, I have your age. Problem with it is every year or so, you're going to have a birth date pass by. And you're going to be another year older and deeper in debt. And I'm going to, and so it's possible to have inconsistent data. Never store anything in a field that you can calculate from the data you have. So it's got to be something that I can't derive any other way. Now, that might get overridden sometime. And in the advanced class, that's one of our, in fact, that's usually the final. I have people, okay, for some reason, we need to do this. So I might have some statistics or something that are possible to calculate from the data, but are so expensive that it's better to keep it up to date. Go ahead.
So when you do that, do you set like a constraint between two tables?
I'm going to say, you're asking me how you do that, how you keep them up to date. We're going to see one way in the next lecture. We're going to create, you mentioned a view a minute ago. We would create a view. A view is a SQL statement that you give a name to and you treat it as if it were a table. And so if my invoices were really an SQ were really two tables, It would be the invoices joined with the invoice line items, and I'd show you the sum of the invoice line items in there, and you'd think it was a table. To you, it looks like a table, except you can't update the invoice line items.
That number's not stored.
The invoice total would not be stored in a table. The invoice total would be calculated every time you looked at that, and that's what we're going to see next time. Okay, so that brings me into views. When you create a view, it is another database object. Let me finish up indexing first. Then if I have time, I might introduce the idea of view. How much time do I have left? It's about 11:30. Okay, so my problem is that I can have inconsistent data, so I have a very bad table design here. First place, I have two-factor primary key. Say I don't need that, I can get around that. And the second thing I've got is that I have redundancy of data, in that I have something in the invoices table that depends on a sum coming from the invoice line items, and nothing is checking them to make sure they're the same. Okay. That's very difficult to do. A constraint cannot span tables. A constraint acts only on this table, so I have no way of saying, okay, here's a constraint. I can say check that the sum is less than 500, but I can't say check that the sum is equal to something in another table. A constraint won't do that. There is something that I can use to do that, a little more complicated. Okay, I don't like this. I don't like having the two-factor. The problem with it is that I don't have an index built on any one table, and on either of those fields. I have an index on both of them, but I do not have an index on invoice ID alone, unless I create one. Okay, and I don't like that. Index ID is a foreign key, therefore, if it's a foreign key, it is almost totally humswoggled certain that it's going to have an index. Almost. There might come a reason why you wouldn't, but for the most part, rule of thumb, foreign key, index it. Unless it's just some trivially small table. Okay. This one, I'd get rid of the two-factor key, and I'd definitely get rid of, well, I have to keep the invoice line item amount. I would get rid of the invoice total. That would not be a field in that. So I'd take that field out of the invoices table, and I would replace it with a calculated field that every time you looked at it, you'd see it up to date. But you wouldn't be able to change it in the invoices table. I want you to be able to add a penny to it any place. Okay. So questions on invoice. I believe that the microphones are that people are able to speak. If you're online and wish to speak, you may. Don't have to. Okay. Now, I ask you to do some stuff. I ask you to create some indexes. Okay, it's fairly simple. I ask you what indexes would you create on the AP database. If it's a table of any significant size, foreign keys are indexed, period.
By default.
No, you have to do it. Foreign keys, the system does not build an index on a foreign key. The key thing does the system build an index on it? The system builds an index on unique constraints. So the system has to build an index there, because if I'm going to insert something in a table and that thing has to be unique, that means I have to search the whole table every time I insert. Well, I don't want to do that, so I build an index. That makes it quick to tell whether it's unique or not. Don't have to go retrieve the record. I just, it's either unique or it's not by just looking at the index. So it's worth it. Index is expensive. An index to calculate the cost of an index, a rule of thumb is you take the size of the field that you are indexing in bytes times the number of rows you expect to have, that's n, times log base 2 of n, use your calculator, and that gives you the approximate number of bytes that index will take up. That's a rough estimate. It's usually pretty good. Okay, I'll make the assignment. The assignment on this should be pretty simple. Let's see, I have a few more minutes. I wanted to introduce the next topic that we're going to do. Guess I've lost my modules. Well, I've lost my modules. Okay, indexing. I'm going to go, I've skipped over 12. I'm going to come back to 12. The next topic that we're going to do is database views. Database views are really fairly simple. Essentially, a database view is where I take an SQL statement, take any SQL statement, select from where, any SQL select statement. What does that return? A table. Good. That's what I wanted to hear. An SQL statement, a select statement, returns a table. Always. It might be a table containing one row, one column, one number in it, but it returns a table. Okay. I can give that a name and treat it as if it were a table stored in my database. As I look at it, I'm going to see it as a table, and I can do select from where, from that pseudo table. So a view is an SQL statement that is saved as SQL. The data are not reproduced. So the data have to be derived each time. The cost of using the view is the cost of running the SQL statement that creates it.
Okay. It's sort of like a subquery.
Well, I'm gonna relate it to subqueries as we get. Yes, persistent. In other words, the name persists. Let's see. Have you guys done Access? Ever? Never done Access? You lucky person. You done some Access? And never ever done Access? Heard of it. Well, for those of you, if you do Access, I could bring it up and show you Access. Access is not a bad database. We always we go poo to Access. It's kind of considered a beginning database. It's okay for a very rudimentary treatment. Unfortunately, most of the classes like ITSW 1307, I think it is, they're not really teaching database. I don't mind using Access to teach database. I don't like using a database class to teach Access. And what they do in there a lot is teach Access. It's like if you're teaching database theory. Okay, now when you create a query in Access, yes, you can write SQL in Access. Yes, you can. There's a thing there called database view, or excuse me, SQL view. So you open your SQL window and you can type SQL in there. And you can create a query, select from where. You take any of our select from where statements using, you know, sum and count, group by works, all of it works, table joins work just fine. You can type it in and you can run it and it'll be a query in Access. Access speaks SQL, kind of a strange dialect of it, but for the most part, if you copy and paste most of our stuff, it'll work just fine in there. Now, if it says go, it's not going to work. But what happens is you save the query. You're right. You save the query and you give it a name. I say that's not a query. That's a view. To you, it looks like a table. Well, in Access, it looks like a query. You know, you have it. It's in a different window. But as far as you're concerned, that is a table. So you save it and you give it a name and you save it. An example. Here is a select from where statement. Plain old select from where. It's got a group by in it. That should be, oh yeah, Dr. Smith, we've been there, done that. Thank you very much. Don't bore us with it again. Okay, so I'm going to take this query and I'm going to drop it into a view. And in the view, I give it a name. So I say create view, give it a name. It has to be unique, as, and then my select statement. Now, the thing is that the go has to be bracketed by a go. Anytime you create, by the way, creating is always bracketed by go in SQL Server. So if you create it, let me finish. If you create a table, create table foo, go, create table foo, field, close it, semicolon, go. Create table fee, go. Create table phi, go. Create index, foobar, go. Create view, invoice totals, go. So every create statement is inside of a go, its own go, all by itself. Other things will have to be that way. In general, if you're just running selects, you don't have to say go for every select statement. Some people do. You don't have to. Questions?
Just to clarify, bracketed means like has a go before. So.
Right. Yeah, that means if you ever get the error that you forgot it, it will say if you try to create a view and you have anything else inside of the go. Now, if the file ends there, it's okay. You don't have to say go at the end of it if that's the end of the file. If you just highlight it and run it, you don't have to have a go before or after. But if you're running it in a batch, it's go, create view, go. So if you fail to do that, then it will say, you know, a create view must be in its own batch. And so go, create view, go, puts it in its own batch. Before and after.
So you have two creates, is it 3 goes or 4 goes?
Well, it's one before it and one after it. I don't care how many you use. You can use 12 if you want to. So you can go, 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 go. If you have 2 creates, you would have a go before it, a go between them, a go after. 3 would be a good idea. You know, if that's the end of the file, I usually put a go there anyway. Everlastingly, I'm coming along putting something after it. Okay, I'm not going to go a whole lot into views. Views are usually that's a pretty easy lesson, so I want to leave some time for review. So next time we're going to take care of the views. By the way, we've seen views before, believe it or not. Back in chapter, let's see, what chapter were the subselects? What module was that? Module 8, I believe. 7 or 8, where we did, it might have been 7, where we did the subselects. Remember when we did the, let me see if I can find it. $14 is the views. Subqueries, yes, module 8. Let's look at page 5, derived tables. Remember that derived table we're selecting from? Guess what that is? I gave it a name. Its name is D. Now, it's not saved in the database, but that is a view. That's how a view works. I could have said create view D as, given it this code. I could have said create view. Up here, I would have said create view D as, and then I would have given it that, then go. And then down in the select, I would have said select vendor name MyMax from D. That's a view. In fact, instead of using a derived table, many times I will create a view. If I'm going to do it very often, if I'm going to reuse it, a view is handy. A view is cheap. A view does not reproduce the data. Okay. Goodness, it's 11:44. I believe all of the microphones are unmuted. So if anybody, any questions that you'd like to ask? Meaning anybody who hears me can speak up now. I'm pausing. It's been my experience that I have to shut up for a couple of minutes to give people time to think of a question. Hardest thing in the world is getting a teacher to stop talking.
Well, if no one else has a question, I have a semi-related question. This is Doug.
Okay.
From what we've learned in this course, would we be prepared to sit for the Microsoft SQL Server certification exam?
I would suggest before you do that, you get some preparation material on it.
Okay.
The SQL Server asks a lot of questions about that go directly to installation and tuning of SQL Server. So it's more than just SQL. So yes, you would be able to do the SQL portion. But there will be a lot of things about, for example, I can give you one topic that I know is on there.
You like questions about the studio program?
Questions about Studio. So there'd be some stuff. Let me, since I am now recording, so this will be on the recording. You might want to watch this. This is from the advanced class. You might want to watch this video on show plan.
Okay.
That is one example. Now that's a short lecture and it's appropriate to this class, so you'll probably need to practice with it a little bit. Another topic that's on there is the isolation levels. So one of them, the show plan tells me how well, excuse me a minute. Okay, show plan says how will the system actually access your stuff. So in show plan, I can see what indexes it's using. Is it using the indexes?
That looks interesting, yes.
Okay, it's a real nice little lecture. It's about 15 or 20 minutes. Another one is isolation levels. Isolation level says, what am I willing to accept? Am I willing to allow myself to read data that you are now in the process of changing? For example, in the old days, we had the Sabre system, reservation system. It was an early airline reservation system.
Yeah.
And it would allow two agents to sell the same seat to two different people. So that's what's called a dirty read. In other words, somebody is currently selling a seat and it will allow you to sell it also at the same time.
Okay.
Back at that time in history, it was just cheaper to give the second guy a free ticket, and so they just didn't sue you. They usually would know it, they'd done it, but sometimes they didn't even know they'd done it. And you'd have two people show up for the flight that both had tickets. Concert tickets had the same problem.
Yeah.
Anyway, we've pretty well fixed that, but that's isolation level. In other words, I don't want to see data that you might be changing. So, or is it okay if I see it as long as I don't sell the seat? Kind of thing. So that's called the idea of dirty reads. And If
Well,
I'm so,
some concert ticket sites, they'll say that your order is valid for the next 5 minutes unless you click OK. So it probably
right.
sends it back after the 5 minutes. Yeah, that makes sense.
Yeah, it probably it locks it up and it says nobody can see it, but there has to be a timeout on it.
Right.
So I won't sell that seat for the next. Usually it's about 15 seconds. I won't. 5 minutes is a long time. Another one is if I want to know the how much I want to sum a group of records, I have to make sure that nobody comes along and inserts a record into that group while I'm doing the sum, because then I don't know whether I've got the good. So I have to block you from inserting. So that's isolation level. You talk about that. I would recommend paying particular attention to them, and you might look at installing SQL Server installation. We did a fairly simple install. Actually, it's a lot more complicated than that. If you are needing to call it a day, go somewhere, you may. Okay, did I answer your question, Doug, I guess?
Yes, thank you. So from your perspective, with what we've learned in this course plus some extra, would we be ready to sit for the exam, or would we need to take another like review course or something?
I would probably recommend a review course. This gives you a background in SQL.
Gotcha.
But the SQL Server course, the certification is more than that. Have you done any certification tests before?
Yes, I'm mainly on SAS, not on Microsoft.
Okay.
Yeah.
Well, then you know what they are.
Sure.
So it's going to ask about Microsoft SQL Server. So I've tried to keep this class generic SQL, what I'm calling pure SQL. I can't always do that, but I'm trying to focus on SQL, but there's a lot of proprietary stuff.
Right, sure.
Server statistics are another area that you'd be asked about. Okay.
Okay, thank you.
Other questions? SQL proper, we've about exhausted it. Just SQL. If you're staying in pure SQL, there isn't a whole lot more to do. Everything else is built on this. To take the next class or to go on from here, you need to be pretty much up to speed in your select from where. That means table joins, all kinds of them, subqueries, aggregate function, group by, also creating tables, table constraints, what is a primary key, indexing is another big one, and views. Once we get through that, there just isn't much else I can do with SQL if I have to stay in SQL. When you get into the advanced programming now, look, my SQL program, my SQL statement is my world for right now. And now I step outside of my world and I say, hey, this is cool. I could have two of these. So I have two SQL statements and they can talk to each other. So I have the ability now in the larger picture to put stuff into a variable and then send that to the next SQL statement. I do use Visual Studio in it. I allow people to write in whatever language they like there. For example, you can write in Visual Basic, or I allow C# or Java, I suppose. So it's pretty complicated. So yes, we do some form writing. Most of the time I try to keep the forms pretty simple. So just, inserting into the table from a form, basic interaction. We do user-defined procedures, functions, functions that return tables. And no, that's beyond the scope of this class. Oh, functions. Well, okay, functions are defined in, we covered that. the length of a string. That's a function. So it's a function that is defined in SQL. So the len of a string is part of SQL. But we will be able to write our own functions. So, and procedures. So those of you who've had a programming language, it's pretty important that you have a programming language. Prior to that, you have to be able to program to take the advanced class, meaning you should have seen a class like C, Visual Basic, Java, just to have an idea of how they all work. But nice to have seen something else. It shouldn't be the brand new stuff.
So you said like in the spring there will be the advanced SQL will offer.
I doubt it will be offered in the spring. It is not on the catalog for the spring. It is usually a course that is offered in the fall.
Oh, okay. So would you recommend to go for learning? I am currently taking Java. So Java 2. So would you recommend to take SAS programming or wait for the advanced?
SAS and the statistical packages, what was SAS? Statistical, actuarial, something.
Statistical analysis system.
Okay.
Nowadays, most people are taking R rather than SAS.
Right. You also have SPSS is real popular. Gee, I don't know what to tell you. I don't teach that class, so I've got to kind of need to. I'd be just giving you what I think. I'm thinking it's probably something completely different from ITSC 2347. I know what 2347 is.
Well,
So, learning
I'm certified on
Okay,
SAS.
okay. Well, two people at once. Go ahead, Anita.
So learning Python is a better idea to go advance in SQL.
Well, except that advanced SQL, advanced database programming is not offered next semester. So that's a decision you'll have to make. There is a class that is offered. Let me see if I can pull it up quickly. Here. Let's see, that is faculty. Come on. Anytime today, Cougar Web. Descriptive analytics. ITSC 2370. That is a statistics class that meets on Monday evenings here. I notice I don't have a whole lot of people, but that's not unusual at this time. Descriptive analytics.
But again, it's not offering in the spring.
Yes, that one is offered next semester. Descriptive analytics is.
That's an Excel.
It's mostly an Excel. It doesn't have to be. It's not about Excel. We use Excel as the platform. So I try to get away from teaching a class that is about the specific software. Right. I try to get away from teaching SQL Server, although I have taught just SQL Server. So now it becomes a question of like, how does SQL Server start up? How does SQL Server resolve something, recover from a crash? And those questions would be on a certification test. Also would be SQL. So you're ready for the SQL part, but not necessarily all of it. Because I have de-emphasized that which is unique to SQL Server. If you're going to take a cert course, I do recommend taking one of their one of the commercially available classes.
Are those really expensive?
Oh, I don't know how much. What? Not the continuing ed. I'm thinking of the ones that are offered by Microsoft, where you go. Usually, it's given at a hotel meeting room or something, and you go and avoid the ones that are all day classes. Your brain is fried by the end of the day. So you want something that has a little bit longer of a span to it. That some of them are like 3 days of 16 hours a day. And those kill me. And I find my retention is very poor in those. And then at the end of the 3 days, the last 3 hours of the 3 days, you go take the cert test. So you talk about walking out of someplace shaking. I mean, you know, it's not a pleasant experience. Other questions? Okay, I'm going to end the recording now. Thank you.